First off, I got a message today asking me to announce career fair by the Computer Forum. That's next Wednesday in the lawn between the Hewlett Teaching Center and Gilbert Building. So if you're looking for a job, maybe head out there. I've gotten about a dozen emails from students so far, and I'd love to hear from you. So, feel free to contact me. Again, the class website is cs193s.stanford.edu, and you can find an email address to send to myself and to the CAs. So I was just wondering if anyone had taken a little bit of time to try setting up GWT GUID on Eclipse, and if anyone had any questions or problems that we could address right away. All right. Yep.
I tried to install Subversion
Uh-huh.
on the Mac. Do you have to have Apache 2.0 or something like that on there? Or
What version of the Mac OS do you have?
I have Snow Leopard.
It has Subversion built in.
Oh, does it?
You don't have to do anything else, actually.
Yes. Okay. Cool. Thanks.
Yeah, we could put out a link to how to use Subversion command line. It's built into the operating system.
Okay. That'd be cool.
There are user interface programs that add a front end essentially to Subversion, so that you could get it from a menu instead of from the command line, and that seems to work reasonably well as well. Cool. Oh, yes.
There are plugins for Eclipse that do the same thing, so you don't have to worry about
The Subversion. Okay, great.
Subversive.
I think there's one with Eclipse or something as well.
Yeah. Actually, if anyone has opinions on either or both of those, I couldn't really distinguish on the web which one was better, or which one seemed to have more momentum. They seem to both be pretty good. Great. So just for review, there was one thing that wasn't clear last week or on Tuesday when I brought this up. I'm planning to have 3 programming assignments, and the red stars indicate here that the due date. So they'll generally be due on the Thursday of a given week. So these are the 10 weeks of the course. So the first one would be due 2 weeks from today, and I'll basically be handing out the assignment on Tuesday. Not a very big assignment, but at least it's something to get us started, to get us rolling. And the bigger project will be due on the end of the 7th week, which is towards the middle of February, and the last one early March 4th. Great. So basically, I just wanted to do a real quick review from Tuesday's class. I think Big is really one of the things I want to encourage people to continue doing all throughout the quarter in terms of what scalability means, because it's really not so much about writing tons of code, but extending your capabilities at some level. And the 3, I think, takeaways from Tuesday were that scalability really is about handling growth in a very dynamic environment, and that Java and open source are a really good environment in which to learn all of these scalable practices, and that when you start talking to a lot of different people, you find that everybody thinks about innovation and scalability in very different ways. And I'm going to focus a little bit more on the impact that all of those different ways of thinking have on engineers, but we'll come at it from an engineer's perspective. Cool. The one thing I'd like to add to that is that, listening to you guys on Tuesday and hearing your questions, I realized that I was going to have to change a little bit the way I approach the course as well. So today I'm going to try to make a fool out of myself and install MySQL on my laptop and add some databases in and run a few queries. And the whole purpose being that I don't want people to feel too worried about installing lots of different software, and I just want to show that it's not as daunting a thing as it might appear. MySQL has gotten very user friendly and very install friendly over time, and I thought it would be fun to sort of put together a fun data set for today and then just do a couple of queries and see what comes out. We'll see how that goes, but it's an opportunity for a little laughter at my expense, perhaps. So this was something I thought would be kind of fun to sort of bring up as like just a fun thing to look at for the first new slide of the day. And it's got a lot of zeros. Shortly after these bills were actually issued and put into circulation, Zimbabwe suspended its currency. So nowadays you basically have to use foreign currencies within Zimbabwe to buy and sell things. But so this is something that happens when kind of a feedback process runs out of control. And it's happened actually a number of times in the past. Zimbabwe is the most recent case, and it's actually this is the bill that has the most zeros on it ever issued in the world. But in Hungary, after the World War II, they actually printed some bills where they gave up printing the numbers of zeros, and they just had a big letter B to stand for, billion, which meant trillion, I think, in there. In European languages. So anyway, so sometimes things get a little bit amok, and I'd like to connect this back to the topic of the course during the course of the slides, but I thought it'd be fun to just take a look at it. So anyway, obviously it didn't work for long. To really dig into today's class, I thought it'd be fun to sort of position web programming within all of computer science and say that, I think web programming is really exciting because it's sort of on the borderline of, what's really impossible to do, as the complexity theorists tell us, and what's maybe a little bit too trivial to do. What you can do on your own. And so I think web programming is a perfect example of a really rich area in the discipline where boundaries are always getting pushed, and there's a ton of exploration going on. So that's one of the reasons I'm really excited about teaching this class, is because I think that there's so much meat here, and to really get into it and feel comfortable doing it, sometimes it seems like there's so many different technologies you have to deal with. And I think that now there's a number of really cool competing frameworks that are available that simplify that. So I talked about computer science as a discipline, and some complexity theorists came up with this stack of different complexity levels. And for me, web programming tends to always be the type of discipline that's pushing the boundary, that green boundary of what's feasible in complexity. And so that's, for me, that's one of the really exciting things about it. This isn't going to be on the test, by the way. No test. But just sort of, I like having, some kinds of, visual presentation of what a domain looks like, so that you can position yourself within it, get some context, and then start to feel comfortable with what it is you're doing within the within the domain. And I wanted to, sort of motivate some of the discussion with YouTube as an example. And each class, I'm going to try and talk a little bit about either a company I worked at or a company that I observed while I was in the middle of, startup heaven or startup hell, depending. So YouTube is a great example of tremendous growth, and it's a company that's managed to go from a very small amount of content to literally billions of content and unheard of amounts of bandwidth. Even within Google, they hadn't been concerning themselves with bandwidth that YouTube was generating. But definitely one of the things that happened at YouTube was that while they were fighting, this constant growth, they weren't able to really create a lot of rich features into their service. And, some people will say, well, that's not really a hindrance. It didn't prevent them from growing. But there were a lot of things that they always said they were going to do that they ended up pushing out a lot. And so when you're fighting scale, that tends to be one of the problems you run into. And at a certain point, the Google acquisition just really made sense because Google did really have all of the infrastructure background to allow YouTube to continue growing by several orders of magnitude, even after the acquisition. And I think that if they hadn't been acquired, you would have probably started to see them hitting certain bottlenecks that they managed to avoid by meshing into Google's infrastructure. On the other hand, the acquisition may have really delayed their revenue model development because all of a sudden the pressure was off on how to make money off of the site. Mm-hmm.
You said they would have hit that wall. Was that because of the lack of technical expertise or the lack of funding to?
Well, a little bit of both. I think that they were basically growing so much faster than, say, Google did, that they just their time frame for learning how to grow internally was just so short. And Google's growth has been just tremendous from 10 years back on, but they've had more time to become experts at all of the aspects of growing the service while they were doing it. And I think that by the time YouTube came on, they were they were ready for them, basically. So scaling really does introduce all sorts of problems, and again, on a weekly basis, I will try and bring back this idea that it's not just about the code; it's all these other factors that sort of affect how your code is going to go. So one of the things that's interesting about data that goes up on websites is that, and particularly all of the social websites, social media sites that have developed over time, is that a lot of data is accumulated by contributors in a short period of time, and it's observed by an even larger number of people. And these pieces of data are not completely independent of each other. Whenever something exciting happens in the outside world, people put up footage of it, and there might be 100 submissions that are similar. Or if someone likes it, they'll copy it and they'll submit it themselves. Or things get resubmitted, etc. And then they're connected to other things that relate to them. So on a site like YouTube, what you see is really this very interesting structure of data. It's not all independent videos. It's videos that are connected by the people who submitted. It's connected by the people who have ranked them or commented on them. So you get this incredible dense network of connections between all of the data, and that dependency induces what are called power law distributions over that data. You may also have heard of power law distributions from the term long tail. And the reason I'm bringing these up is that they're prevalent throughout, all of the websites and that you might consider building in the foreseeable future. And so you want to architect to deal with data that's structured like this. So power law distributions. It seems like anything that's accumulated over time that humans have produced can somehow be visualized through some power law. And it basically just has a lot to do with the way the way our minds work and the way we collect information. And each of us as contributors or viewers of content basically have our spectrum of things that we're interested in, and the sum of all of those spectrums of interest appears to induce this structure on data. They're called power law distributions because if you plot them on a graph in a log-log scale, and I'll show one on the next slide, they follow a straight line, and that straight line, that slope of that straight line corresponds to a coefficient. That relates the x-axis to the y-axis. So the example that I pulled up last night as I was preparing these slides was a distribution of web traffic referral. So on this slide, what you're seeing is basically one website and all of the referrers of traffic graphed for that website. And so some referrers refer a lot of people to that website. Other referrers refer, relatively few. And when you plot them on this graph, you see that there's a really nice straight line that that sort of relates them. And so this stuff just tends to appear over and over and over again as you're developing websites. And one of the goals that you would have if you were building a site that you wanted to get attention would be to have your top referrer be somebody like Google.
What is the x-axis?
Okay, yes. So if you look at the x-axis, it says referring page, rank ordered. It means that, they collected about statistics for about 1,000 pages from which people went to their site. And they basically counted the number of times somebody went from the site to theirs, and then they sorted that so that they put in rank number 1 the website that sent the most traffic to them, in rank number 2, the next website that sent them traffic, etc. So, yeah. So basically, all of the x-axis points correspond to a website that sent them traffic, and it's just been sorted in order of how many pages referrals they got. Yes?
So that's, by definition, monotonically decreasing?
Yes. By the
the
fact that you sort it, yeah. And a lot of these graphs are graphs that are going to be rank ordered. You get statistics on some aspect of your site, and then you order by frequency, and you plot it. But it's really a good way to understand how your website works, and who's important. Basically, if you're spending a lot of time getting these guys to try and send you more traffic, you're probably not getting as much bang for your buck as if you focus on the top 10 or 20. Cool. But remarkably, even if you do spend a lot of time on the top, 10 or 20, the rest follow follow suit at some level. So you may increase the number of page views that you get overall, and what you'll find is that you'll have increased the ones at the top of the distribution, but the other ones will have also kind of followed along. Yep.
So, what do you mean by focusing on the top 10%? Are you saying that, practically speaking?
Practically speaking, if you spend time building relationships with the top 10 referrers of traffic to your site and understanding, why it is they're sending traffic to you and getting better at it, you're going to end up with a more popular website. And what seems to happen is that popularity then drives the effort on the ones that are lower down in the distribution. Okay. Cool. So indeed, the reason that I'm bringing all this stuff up so early in the quarter is because it really is relevant to how you would structure your service, and not only in terms of what you do on the back end with databases and stuff like that, or how you set up your caches, but it can also really help to understand this with respect to web page design, because you're going to want to design your web pages in such a way that you don't really get hammered when your site becomes really popular and it becomes very difficult to pull all of the data that you would like to pull for a given page up. So designing a really good website ultimately involves, thinking about all of these constraints on the data level, even from the web page level all the way down. Okay. And actually, maybe just to speak to a couple of these, if we go back to this kind of slide, if you cache the most popular pages on your site very carefully, then you can avoid having to hit the databases on the back end for a large percentage of your traffic. So the top top X number of pages on your site might constitute upwards of 50% of the traffic to your site, and if you cache them properly, you're saving yourself a lot of bandwidth and a lot of cycles on the back end. And it affects things like database partitioning ultimately, because the connections between web pages are really not very simple. They're so entangled that it's impossible to sort of cleanly partition your data such that, say A through B is on one server and C through F is on another server and G through M on another server. Because basically any kind of naive partitioning, and even sophisticated ones, run into problems where you're going to have to hit multiple servers to handle a request. So you basically have to design your back-end system to support those requests coming from multiple databases. Cool. So other examples. I basically wanted to reiterate that it's not just on your websites that you see this type of stuff, but basically throughout any human activity sort of creates artifacts that seem to be connected in this way. And human languages have very similar properties when you look at frequency of usage and in social networks, when you look at links between users, both for bidirectional friend links and also for Twitter-style fan links, you have exactly the same kind of structures that arise. So in financial markets, transactions are often organized in a very similar way. You'll find that the most popular stocks and the least popular stocks can be ranked in very much the same way. And I'm not talking about the change in dollar value of the stocks. I'm just talking about like how many transactions are done on the stocks during the course of a period of time. research citations, also the most popular citations and the least popular can be ranked and ordered like this. The 6 degrees of Kevin Bacon, also very much the same structure. I did a bunch of work on this in my PhD research, and I called them nexus to describe the overall thing. And it turns out that the web as a whole is structured in this way. And the individual social networks that I've worked at also are structured in this way. And then in my PhD studies, I looked at the English language and English language dictionaries, and the vocabularies are also structured in this way. So they're pretty ubiquitous in sort of human created artifacts. And the reason they're so ubiquitous is that there's a very simple process that generates them. Basically, if you can describe the universe of things that you want to deal with in terms of objects and links, and then the environment is the universe is one in which new objects are created or new links are created, and sometimes those objects and links can be removed. So if you just design a process that does that, there's really only one sort of thing that you have to do to make sure that the structure is induced, and it's that the new link probability is based on the existing structure. So if you're already linked to something, it's more likely that you'll link to things that thing is linked to than something you're not linked to. So basically, and to sort of relate that back to us as individuals, it's more likely that I'll meet a friend who's a friend of, or I'll meet a new friend who's a friend of an existing friend of mine, than I'll meet someone completely out of the blue. And typically when I meet someone, quote unquote, out of the blue, it's because maybe there's an activity in common, or some sort of I guess interest that links the two of us together. So basically all you need to do to generate these types of structures is a very, very simple iterative process that creates objects, creates links, and creates those links based on the existing structure. Before we left the topic, I thought I'd put up, this is based on some UN statistics of the population growth. So Earth population starting in 1800, and they're basically hoping at the UN that we'll follow the green path. And that's getting us to a peak of about 7.5 billion people in 2040 or so. But they're thinking that it's more likely that we'll have a couple more billion than that by then. But this curve here is basically an exponential, and a lot of that scaling has been enabled by the growth of technology, and so improved farming and ability to build equipment that multiplies our force essentially. What follows is basically, we're hoping to constrain that before we reach the limits of what the Earth can sustain. So anyway, I think it's always fun to take a real world piece of data and look at it and see what happens. One more thing to sort of discuss on this is that there's a lot you can learn from looking at specific other environments that are similar to the one that we're dealing with. And I brought up three types of environments depending on what your interests are. So if you're interested in markets and economies, if you're interested in finance, maybe you're more familiar with producer-consumer relationships and commerce. And if you really understand how products are created and are sold and how consumers take to them or don't, the knowledge that you take from that can be applied to building websites, because at a certain level, what you're going to try and do is produce some content that people are going to be consuming. If you're more into things like government or anthropology or something like that, you might look at how societies and organizations live and die, and what causes them to thrive versus not. And there's many things you can take from that to understand how a user population for your website may become very vibrant, or it may stagnate. And you might want to design your software in such a way that it encourages the behaviors that create a thriving society. In habitats and ecosystems, if you're into biology, you can look at the way new species arise and the way that they populate niches within their environments, and understand that when you're building a website, it's very similar. There's a whole ecosystem of other websites out there, and you're basically trying to find your place in the sun amidst 100,000 or 1 million other sites that are competing for the same user's attention. And understanding things about the way ecosystems work can help you make better decisions about how to make your websites grow and thrive, and how to take on bigger and bigger niches. All right. So back to software. I brought some of these things up in the last class, but what I think is really important is that there's so much technology here, and there just isn't a whole lot of time in order to get a startup up and going, or if you've got a big project to do. You basically want to do things in such a way that you're most efficient for what you need to get done. When it comes to operating in the classroom, it's most likely that you're going to learn practices that are very efficient for one person. But when you get into industry, it's rare that you're able to continue operating all on your own. So I think that basically, the purpose here is to look at how we go beyond single programmer to multiple programmer environments, and what are the kinds of things that make it easier to take that step. So actually, before class, I was talking to my CA Aditya about Eclipse, and about the fact that the compile cycle for Eclipse, or the compile and test cycle for Eclipse, is a little bit slower than it is for frameworks like Ruby on Rails. And so sometimes that's something that you have to sort of figure out how to overcome. And definitely for rapid prototyping, there's the environments that are a little bit faster than the Java environment. But when it comes to maintenance over time and dealing with software over the course of multiple years, you end up actually with some pretty real benefits in biting the bullet early on and going with something like Java.
Can you specify that? Can you expand on that?
Sure. I think the biggest area where it makes a difference is in software maintenance. So once your code reaches a certain size, there's a tendency to either not ever want to touch it again, because you don't know how it works and how it breaks anymore, or you get to a point where it's very hard to add on new functionality because you don't know where to tack it on. What I found is that by building a lot of unit tests in as you develop the code, you're more able to adapt and modify your code and pull out large chunks of it because you can be much more confident about the way the software works as you put the new components in, because you can test them and see whether all of the tests run the same way that the old tests on the old infrastructure did.
A quick question on Ruby.
Mhm.
So like the big companies like Microsoft, Google, Yahoo, none of them there's 0 job listings for Ruby programmers.
Mhm.
You go to Craigslist, all these smaller companies, they're all using Ruby. So
Right.
back to your earlier comment about Java versus Ruby and software maintainability, how does that relate to,
Well,
why do you think that is?
I think that basically it's an issue of scale ultimately. So Ruby works very well for rapid prototyping, getting something off the ground pretty quickly, and once you're comfortable in that framework, you can get a lot accomplished in a short period of time, and you can scale that pretty well to small teams. But once the code base gets rather large, it does get a lot more difficult. And you know, I'm sure that the Ruby on Rails people are not standing still, and they're thinking a lot about improving the way you can do unit testing and the way you can create maintainable structures over time. But basically, it's been, I think, for that reason that the bigger guys end up not using Ruby on Rails. And if you look at some of the problems that Twitter has had over time, they're one of the biggest installations that's Ruby on Rails based, and I think they basically paid the price for sort of not thinking about some of the scalability issues early on. On the other hand, I don't know how many of you followed the growth of Twitter carefully. But Twitter was born out of the embers of another company, Odeo, and Odeo had been a competitor to iMeme, the company I founded, and so I was paying attention to Odeo a lot. And all of a sudden, we saw that they sort of tossed this thing out into the world called Twitter, and we're like, what the heck are they doing? And they got to be kidding, right? And we thought Odeo was a real competitor, but we had no idea how big of a competitor, or a partner in the internet space Twitter could become. But clearly, what they did was they threw together a prototype they were able to get out there very quickly, and then they just maintained it as it grew and as it gained a lot of interest from the world outside. So so I think that this the coding and testing cycle is one of those areas where Ruby gives you a lot of productivity early on. But if you are able to set up your environment with Java and GUID and Subversion or Git and with the unit testing properly, you can actually get a lot of productivity over the long term. So what I thought that's very different about today's class compared to last class, that I'd actually just do some stuff together with you with SQL, and in particular MySQL. I feel like it's important that we see how easy it is to do a few things in MySQL, and that that basically some of the things I'm talking about can form the basis of how you could approach installing and using MySQL in your own projects, and then any other tool for that matter. So I'm gonna drop away from the slides for a while, and I'm gonna install MySQL on my laptop, and you guys are gonna watch me do it and be bored for a minute or two while I chat. But I just felt like the MySQL install is so easy that it's worth demonstrating and just doing a couple of sample queries on it. So instead of going to the internet, I'm actually just going to pretend that my USB key is the internet. All right, so I'm downloading it. And running into something unusual here. Well, this is unexpected. All right, so let's see. Just well, I'm finding that this is not exactly what I intended to show you guys. All right. Oh, hang on. Came up right as I. All right. So, yeah, I'll talk a little bit about the data set that I put together yesterday. There's the Social Security website puts together a list every year of popular names in the United States. And I don't know if you've ever run into this stuff before, but you know, it's possible from that website to sort of get for every year starting in 1880 the 1,000 most popular names for boys and girls. And unfortunately, they don't let you download it in any convenient way. But if you do a little bit of web scraping, you can figure out how to basically get the web page back for the data for a given year, and you can take the data from the table and turn it into a text file that a database can then ingest. And so I basically yesterday I went and downloaded that stuff and put it into database format and put it up on the class website. So I'd really like if you guys set up MySQL on your computers to feel free to download that data and insert it into the database and then just run a few queries on it. All right. There we go. For whatever reason, it didn't. Okay, so now we can get to it. So basically, just with all the standard installation, yeah, I got the caps. So, nothing canned. All right. Okay. So this is the file that I put up on the website, popnames.txt. And let's... So let's see. No database selected. So basically what I'm doing now is just reading the data that's in the popnames text file into the test database. So this is a database that I generated yesterday, and then I dumped it out to a text file using a piece of code called MySQL dump. And MySQL dump is great if you want to sort of archive the state of your database at any given time. All right, so that's pretty fast, and then okay, so let's see, yeah, let's see, I think. I guess. Yeah, I'll just use desk. Okay, so the database basically looks like this. If I do select star from pop names, where order by count desk. So basically, these are the top 20 most popular entries in the database. So in the year 1947, there were 99,000 babies registered for social security numbers with the name, the first name Linda. So anyway, it's kind of a fun little database. You can definitely see from this that the baby boom was a very real phenomenon, because like the most common names all sort of showed up there. Anyway, so I don't know if you'd like to take a look at the data in any more detail, but basically I just wanted to show you as best I could that setting up MySQL is not that hard. For OS 10, there's one little additional trick that I've put on the slides. So if you take a look at the slides tonight, you can see there's one command line argument that helps with this. But I think anyway the data set is kind of an interesting one to explore from the standpoint of if you were thinking of building a website, this is the type of data that maybe a lot of people would be interested in if it's formatted the right way. And in fact, there is a website called I think babynames.com, which does sort of an interactive graphical visualization of how the popularity of names has changed over time. I can do a couple of other fun ones, like so select left name one, I didn't aggregate it properly. So this is actually these are initials. Yeah. Yeah. Oh yeah, that's what I need to do. Sorry, that's what I didn't aggregate properly. Much more fun. Okay, so this is for the 26 letters of the alphabet. How common they are as initials, and we can add an order by. Some count. So you can see that U is the least popular initial for a first name, and J is the most popular. So anyway, there's a lot to explore in a data set like this. As you can see, over 130 years, there's 40 million people whose name starts with J in that data set, including myself. And let's get back to the slides. There we go. Yeah. So that third line on the slide here is actually the one little thing you might want to do on macOS to make it easier to play around with MySQL. I listed a couple of other types of queries that you can do. But for me, in order to explore a data set, basically the most important things that you end up using a lot is the group by and order by functions. Let's see. When I got into startup land from academia, I had no idea about any of the tools that existed around a database system. And MySQL has a bunch of really useful tools that make it a lot easier to, basically import data, export data, and then manipulate schemas in a GUI fashion. And then connectors so that you can use MySQL from just about any programming language. For data analysis, like I said, group by and order by operations in a query that you see, for instance, right there, group by name, order by total. Those are ones that you don't really spend as much time learning carefully in class, but they're the ones that I end up using every time I ever touch a data set. So those are definitely the things that where all the interesting stuff comes out. I mentioned the Social Security website, and I basically used a number of little command line tools to extract the data from the tables and put them into a text file, which I then imported into MySQL using this command, load data local in file, which is actually pretty much equivalent to MySQL import. This one you use from the command line, and this one you use from within MySQL. I wanted to sort of start talking a little bit about schemas and the types of things you might want to store in a database for a website that you're building. And I think that the first one to talk about that matters is the user account table. And this is really not the table for all of the data that is going to be associated with an account, but for all of the data that's sort of private and needs to be restricted to that one user. And basically, one of the big important do's about setting up one of these websites is to really keep all of that stuff separate. So the user account table is one where you keep all of the most important things relating to every new entity that comes into the system. You can actually keep information about non-members. It might be a cookie value or something like that that allows you to identify people before they've decided to start an account. But this is all stuff that's really restricted to that one user and should be kept very carefully and very privately. And when we get to the privacy part of the class, I'll talk a little bit more about that, because very often, there's all sorts of abuses that go on even within the startups that are running these websites, and it's just good to know. I mean, website entrepreneurs are not bankers, and they don't really have the experience of dealing with people for a long time, and they don't necessarily have a good sense of how to respect other people's information. And I don't know. I've spent a lot of time sort of witnessing the transformation of Google from a company that was completely anonymous and never had any user information whatsoever that was identifiable, to having sites like Orkut and Gmail and et cetera, that have accounts associated with them. And I think that they face some very interesting transitions there in dealing with data that was by its very nature, anonymous at first to data that was completely identified. And I think they've had some recent stumbles relating to privacy and security that I think harken back to their original perspective on anonymous data. Anyway, so this is just a suggestion for like things that you absolutely definitely want to see in a user account table. But there's all sorts of things like you might want to store a cookie, for instance. You might want to store successful or failed login attempts, things like that, or when the account was created, etc. The secret questions and stuff like that. Okay. So again, I thought I'd take a little bit of time now to do questions and answers, and we could talk a little bit about the stuff we've seen here, or we could look at a few more queries, or I don't know, whatever it is you'd like to do.
Talk a little bit more about Hibernate. How that's useful, I guess.
Sure. Well, so it didn't come up in the slides at all, but there's a lot of ways that you can persist your data. And if you don't have a real database background, you can basically install something called Hibernate that allows you to sort of take all of your classes, or only the ones that you need to store, and store them within a database system. So you end up not having to look very carefully at the database backend or having to know too much about it, because you define in the software abstraction layer the things that you want to persist, and then at the appropriate time you send them out to the database. Will we for Hibernate? Well, yeah, we'll look at a couple things there a little bit more when we get more into the database part of the class, the server part of the class. Why don't I'll take yours.
Yeah. Have you worked with any like of the open source databases like Hadoop or those ones, like, or the Amazon one? I forgot.
So it's like a MapReduce framework, right? Yeah. So I've used it a little bit. I've not had to use it in an area where scalability was critical. And I actually ended up building my own infrastructure in .NET for things that I needed in the startup that I was working at. So MapReduce in its basic form is actually a fairly simple idea, and you can code the basic parts of it in not that many lines, a few hundred to a few thousand.
Can you just clarify what MapReduce is?
Yes. So MapReduce is a framework that lets you basically take, say, a request and farm it out to a lot of different servers that can each send their responses back and collect and then filter those results once you've gotten them all back. So basically, it's kind of a distributed sort of request-response mechanism, but it's very convenient for, say, accessing a lot of data servers or accessing a lot of compute servers or something like that on the back end. And Hadoop is one example of that. But as far as open source databases are concerned, I've used Postgres a little, MySQL very extensively, SQLite a lot. I think SQLite is a great little database, and it's a big efficiency improver. I think I may have, put them on the worth checking out slide. It's a tiny database engine that includes most of the SQL92 language specification. But what's great is that it compiles down to a few hundred kilobytes, and you can basically put it wherever you want. I mean, you can add it to whatever software you're writing. And it's even usable as a server database. If you understand your database requirements really well, the performance is good enough for using as a server database. But it exists everywhere. Like any Android phone has SQLite embedded in it. On my Mac, the Mac Mail program uses SQLite, and a lot of other Mac tools use SQLite. So it's ubiquitous because it's small, lightweight, efficient, and does a lot of things. And it's very easy to test. You can build it very easily with almost any compiler. You can install the pre-built packages and start trying queries right away. It's great.
What kind of software and practices procedures do you use for backing up your database?
One of the tools that I've used most extensively for that has been MySQL dump, and then I've also used redundancy as a way to preserve data by having multiple database servers with the same data in them. And with MySQL, you've got great options for basically creating master-slave data sets, and so you can have for any main database, you can have a number of slave databases that contain exactly the same data. And you can use those, for instance, to grow your service out, or you can use individual database servers as like hot backups in case one goes down, and you can use them to dump the data on a regular basis. I mean, it's good to back up as often as you can. What I found is that if you can afford to set up multiple slaves for a given master, you've got enough redundancy there that you technically never have to access your backup tapes. So that I guess that's over time you can start to get an idea of how frequently your systems go down and how frequently you might need to restart things. But I've not run into serious data loss issues that required going to a backup. All right. Any other questions? All right. Well, then I guess we're done for today. So on Tuesday, I'll be looking to sort of present you with the first assignment, and we'll talk a little bit about scalable practices, and I'll continue to try and have real world examples, and also basically some playing around with some real software as well.
Is that first assignment one of the 5 that was listed on?
Yeah. It'll be the unit test. Well, there's really three for grade, and 2 are just to sort of get going. And feel free to install MySQL and try it today.
I'm sorry I missed the